For this video, we're going to keep working with a cylindrical shelf. So let's start with this problem. We want to use cylindrical shelves to find the volumes of a solid obtained by rotating about the x-axis. The region under the curve y equals square root of x from 0 to 1. As you recall, we did this problem in the previous sections and we used the disk. So we still rotating the x-axis, but we use the we cut that part right here, and that sections we go and we rotate it about the x-axis to create the disk. This time we're gonna work with cylindrical shelf. Now, because we work with cylindrical shelf, is gonna be parallel. The height is gonna be parallel to the x-axis. So as you can see, we take that piece, we rotate it, we create the shelf this way. So I'm creating the shelf this way, horizontally. Now, because we're doing this way, we're gonna have to relabel the curve. So instead of y equals to square root of x, we're gonna have to solve for x now. So x is gonna be y squared, right? This is just pretty much from y equals square root of x. Okay, so notice that this time the volumes, okay, don't forget we're dealing with y now, but anyway, it's still from 0 to 1. It's gonna be 2 pi y f of y dy. Okay, so what is the circumference? The circumference in this case is still two pi y. Now you notice that the height, the height of the shelf is 1 minus y squared, right? Because we go from 0 to 1 with the x equals to 1. So that's the boundary right there. So the shelf is going to be 1 minus y squared dy. And then from there, I can take out 2 pi. 0 to 1, I can distribute. Two pi y squared over 2 minus y to the 4th over 4. So we have 2 pi 1/2 minus 1/4, which is 1/4, and you multiply by 2, you get 1/2 times pi. So that's pi over 2. For this problem, if the height, the shelf height confuse you, you can think of it as, I always tell my students, you can think of it as area under the curve, or I'm sorry, area between curves, right? So this is the right and this is the left. Remember, areas between curves, we subtract left from right. So that's how we got the height. So it's 1 minus y squared. So this is y squared right here. And if you turn over like this, you will see that 1 is the top and the y squared is the bottom. So we take top minus bottom. All right, let's take a look at example 4. So for example 4, we have to find the volumes of the solid obtained by rotating about the y-axis. The region bounded by that curve, so that curve, the parabola, is 4x minus x squared, and y equals 3. So you see that it's bounded, right? And then we want to rotate. This is the interesting part. We want to rotate about line x equals 1. So how do we do this problem? So you take a piece, right? And then you rotate it about x equals 1. So we have to figure out the radius. We have to figure out, based on the radius, we know the circumference, and we have to figure out the height. So let's take a look at the radius. The radius of the shell. So you see, if you take a look at this piece right here, right? And then we go from the x equals 1 here, and then we go this far. So that would be the radius. So how do we get the radius? The radius would be x minus 1. You see at x equals 1, if you plug it in, you're gonna get y equals 3. So this one right here is 1, 3, right? So as you can see, so if I draw a line right here, this is the line x equals 1 right there. So you can see that x is higher than 1, right? So that's why I have to take 1, you subtract 1 from x, not x from 1, okay? So hopefully you understand when we take x minus 1 and when we take 1 minus x. So x is greater than 1. Anyway, now that's the radius. So the height, in this case is the function right here. So this is the function, right? So we go from here, the function, and this line is what? This line right here is y minus 3. Once again, I'm gonna think area between curves. So that length right there is gonna be the curve, which is 4x minus x squared, and then you subtract 3. This is y equals 3 right here. So that's how I got the length. That's how I got the height. So I take this part, which is 4x minus x squared, I subtract 3. Okay, so that's the height. Anyway, you can definitely simplify it before we put in the integral. All right, I'm ready. So v equals, and then we go from 1 to 3. Once again, we take care of the x here. So that should be the x values. 2 pi r. So 2 pi r is x minus 1. F of x is negative x squared plus 4x minus 3 dx. Okay? And then if you FOIL, you multiply it out, you're going to get, I'm going to take 2 pi out, 1, 3. If you multiply it out, you're going to get negative x cubed plus 5x squared minus 7x plus 3. dx. Okay, now I'm ready to I'm ready to take the antiderivative. Oh, let me put 2 pi in there. 2 pi. Okay, so we got negative x to the 4th over 4 plus 5x cubed over 3 minus 7x squared over 2 plus 3x. Okay, and then we want to evaluate from 1 to 3. I'm sorry, I'm running out of space. So 1, 3. Okay, so let's plug it in. 3. Minus, and now we're taking care of 1. Okay, and we calculate that. Don't forget to multiply by 2 pi for third. Okay, so the answer is 8 pi over 3. All right.